You are welcome to Science Tutorials with Farmeternity the Schoolboy. Today we are going to take a look at chemistry. And we have a question which says, what mass of potassium triisocarbonate 4 is required to prepare 250 cm³ of a 0.5 molar solution? The relative atomic mass of potassium is 39, oxygen is 16, and carbon is 12. Answer. Okay, to be able to determine the mass of potassium triisocarbonate 4 needed, we need to first of all determine the number of moles of potassium triisocarbonate 4 in a 0.5 molar solution that occupies 250 cm³ volume. And to be able to achieve that, there is a relationship between number of moles and the concentration in mole per dm³ and volume in dm³. This relationship is N is equal to CV, where N is the number of moles, C is the concentration in mole per dm³ or molar concentration or molarity, then V is the volume in dm³. Now, from the question, we are looking for N, then we already have C in the question. C is 0.5 molar solution or mole per dm³ or 0.5 molarity. Now, V is 250 cm³. If you convert it to dm³, it becomes 0.25 dm³. Remember that 1000 cm³ is equal to 1 dm³. So if you have, if you want to convert 250 cm³ to dm³, we don't know the value, we call it x. If you cross multiply, x now becomes 250 cm³ times 1 dm³ all over 1000 cm³. cm³ cancel cm³. That's why we arrive at this. This divided by 1000 will give you 0.25 dm³. All right, let's continue. So having determined, seen the value of C and V, let us now calculate the value of N. N is now 0.5 mole per dm³ times 0.25 dm³. Remember, this is per dm³, so dm³ will cancel dm³. What is left is, the unit left is moles. So that's why we have that N is now equal to 0.125 moles. So there are 0.125 moles of potassium triisocarbonate 4 in a 250 cm³ solution that has solution of potassium triisocarbonate 4 that has a molarity of 0.5. So if that is the case, we can now use this number of moles to determine the mass of potassium required to produce. So to produce this solution, all we need to do is to convert this number of moles to what? Mass. And there is a relationship between number of moles, reacting mass, and the molar mass. The relationship says that number of moles is equal to reacting mass, Rm is reacting mass, Mm is molar mass. If you we are looking for the reacting mass, which is the mass required to make this solution, mass of potassium carbonate. So that implies that Rm, which is the reacting mass, is now equal to number of moles times the molar mass of potassium triisocarbonate 4. Remember, we already calculated number of moles to be 0.125 moles. Now, what is the molar mass of potassium triisocarbonate 4? Now, let's go back. Molar mass of a substance is the mass of 1 mole of that substance. So the substance here, the solute here is potassium triisocarbonate 4. So 1 mole is just something like this. This is how it looks like. This is 1 mole, even though this 1 is negligible, because if one multiplies anything, it stays that same value. So this is how 1 mole, just as 2 moles of this thing can be written as this. This is 2 moles of this compound. Now, we are looking for 1 mole. So if molar mass is a mass of 1 mole, that means molar mass will have a unit of gram per mole, mass of 1 mole. So the mass per mole, so gram per mole is the what? The unit of what? Molar mass. Now, how do we now calculate this molar mass? Now, there are 3 atoms here. There are 3 elements here: potassium, carbon, and oxygen. And these two here means that there are 2 moles of potassium atom in 1 mole of potassium triisocarbonate 4. See, here is 1, which means there is 1 mole of carbon atom in 1 mole of potassium triisocarbonate 4. This O3 means that there are 3 moles of oxygen atom in 1 mole of potassium triisocarbonate 4. So having that in our mind, we put it into consideration here. Remember the one here, the one is still here. We put it down. Now, there are 2 moles of potassium atom. So now we now use the relative atomic mass of potassium and put it here. So 2 times relative atomic mass of potassium in bracket, then plus 1 times relative atomic mass of carbon, 3 times relative atomic mass of what? Oxygen in bracket. So we now replace it with the values. 2 times 39 plus 1 times 12 plus 3 times 16. We add everything. This will give us 78. This will give us 12. This will give us 48. If you sum the total, if you add everything in this bracket, you have 138. Remember the one here, 138. 1 in bracket 138 gram per mole. So this will multiply this one, we now have 138 gram per mole. So the molar mass of potassium triisocarbonate 4 is 138 gram per mole. So if that is the case, we'll now fix it here using the number of moles, put it here, and now calculate the what? The reacting mass. That is the mass of potassium triisocarbonate 4 needed to produce this 0.5 molar solution of 215 cm cube. Now, if you multiply this, it will give us 17.25 gram, because this is per mole. So mole will cancel mole. You now have 17.25 gram. Therefore, the reacting mass is 17.25 gram, which implies that 17.25 gram of potassium triisocarbonate 4 is required to prepare 250 cm cube of a 0.5 mole per dm cube solution of potassium triisocarbonate 4. So this is the answer. That means if you now want to prepare this solution, what you need to do is this: you weigh 17.25 gram of potassium triisocarbonate 4, then get, say, 50 cm cube of water or 100 cm cube of water, dissolve this in the water, form a solution, then make it up to 250 cm cube and shake it well. This solution will have a molarity of 0.5 mole per dm cube. All right. Thank you very much for your attention. Please, if you have any question, feel free to chat me up on the WhatsApp line on the screen. Chat me up anytime. Any question, chat me up there. Then follow us to watch our lectures. You can go to our YouTube channel for academy, SUSEM Academy. You can also go to our general YouTube channel, SUSEM Limited, or you can even go to my personal YouTube channel, Fameternity, the Schoolboy. I am still my humble self, Fameternity, the Schoolboy. See you next time. God bless you.